Hey there, my AP Pre-Calc fellows, or my homies, as some would say, CRWH. Alright, this lesson we're going to be looking at polynomial functions and the rates of change. Some of it will be review, some will go in more depth, and we'll actually explain what's going on. Sound like a plan? Formal definition of a polynomial. A polynomial is any function where written in the form of a to the n, x to the n, plus a to the n minus 1 time, such that n is a non-negative integer. Just so you guys kind of understand what we're saying here, like 5x squared plus 2x is a polynomial. All my powers of x are whole integers, non-negative, where like x to the negative 2 is not. Well, okay, never mind, that was vague. Yeah, no, that's right. Because negative 2 is not non-negative. It is negative. Or like x to the 1/2 is not a polynomial. 1/2 is not an integer. Okay? So keep that in mind. You're looking for whole number powers of all your x's. Okay? Does have to be in that order. One thing we're also going to be talking about is what is the degree, what is the leading coefficient, okay? Your leading coefficient is the number in front of your largest power of x, okay? So what I mean by that is like, if I have 2x plus 6x squared plus 2, my leading coefficient is not the number in front, it's my number in front of my highest power. So it would have been 6. For this one, my degree is my highest power. It would have been 2. If I have a degree of 0, what that looks like is like 5 times x to the 0. Well, x to the 0 is 1, is 5. That's a constant. It's still a polynomial. It's just x has a power of 0. We usually call it constant. Another new terminology we're going to be seeing is this turning point. Another turning point, a fork stuck in the road. Time grabs you by the hand, drags you where to go. All right. A turning point is when you change direction from upwards to downwards. Or we go from increasing to decreasing or decreasing to increasing is a turning point. Okay? And the direction our graph goes is called the end behavior. All right? So let's get into the nitty-gritty of all these and do a few examples today. Sound like a plan? Maxima and minima. I'll try to get this the best I can. All right. So, for any function f, there exists an interval from a to c, such that b, for all x not equal to b, then f has a local max at b where f of x is greater than f, or f of b is greater than f of x. That makes f of b a relative or local. They mean the same thing, okay? Relative or local max. And what that just says is on an interval, it is a max. It's not a global max. It's not the biggest a function can be, but in an area. For example, well, bad example, but when we look at this, we have 2 maxes, right? Now, if I'm just looking at this interval, this is a relative max to that interval. Those are actually absolute maxes because the function doesn't go above them. Now, f has a local min such that f of b is less than f of x, then that is called a relative min or local min. Now, this one's tricky. So this right here would be my local min, my relative min. As it's smaller than all the surrounding values, but it's not the smallest the function can be. Okay, so that's a relative min, because I'm smaller from here to here. I'm not the smallest. Okay, let's do some more. Well, let's do an example. All right. So again, relative, local, it's the same term. So when you hear them, they mean the same thing. So on the graph at the right, if you got your colored pencils handy, that's great. If not, we'll be okay. Shade the intervals that it's increasing in green and decreasing in red. Well, I already have red. What are you doing? Oh, I'm on the keyboard. Goofy, guess it. All right, hold on. Calm down, computer. We're alive right now. All right. So I'm decreasing from here to here. Pretend that's red. Do y'all agree on that? That's my decreasing. And I'm increasing over here, right? It's like Barney, purple and green. All right, that was bad. I should just restart, but I'm not going to. The people, they love it. All right, so B. State the intervals now where it's increasing and decreasing. So I'm increasing on green. So I'm increasing from negative infinity to -1. And I'm increasing from 2 to infinity, right? That's my greens, my intervals. Okay? And then I'm decreasing from -1 to 2. Any questions on that one? If so, ask in class. Now, because of this, when I look at this, label the max and the min. Well, this is a relative max. Not an absolute max, because there's bigger ones, right? But at this point, you go from increasing to decreasing. Oop, I was supposed to give it. But that's my biggest point in that area. Down here, I have a relative min. Okay? There we go. I labeled them. All right, one more. Let's do one more. So I grab my gaffing. I grab my graphing calculator. I grab my graphing calculator, and I'm going to graph this. Should I actually show that? I'm going to grab my graphing calculator. Actually, I went to graph it, and I graphed it. And I'm going to hold off and do this in class so we can do it together in your calculators, because I'm going to show you guys some tips and tricks how to use your calculator to do it. So that's it for today. Enjoy. See y'all on the flippity flop.